Hi and welcome back. Today we are going to take a look at a vintage directional gyroscope handled like eggs. There is here an equipment conditioning label. This thing is unserviceable. It was removed from the aircraft XV-104 in 96. This is a VC-10 aircraft, but we can see that this unit is faulty. There is an excessive drift. It is called the transmitter directional gyro polar path. This system was optimized in order to have something working even close to the pole. This thing was manufactured by Bendix. Okay, so the rotor is inside this ball. It is difficult to see. The rotor is horizontal on that axis here. It is kept horizontal using this switch. So we can see normally we should have 3 connections here. There is one on the bottom side, this black wire here. Depending on the angle of this thing, there is more electrolyte on the left or on the right. So therefore there is an unbalance of resistance between the black wire here and the two other wires. This gravity switch is connected to a torque motor, which is actually on the bottom side here. So you can see the coil of this torque motor. The torque applied on that axis permits to modify actually the horizontality of that ball. So this permits to keep the ball horizontal. And on the top we should have here a synchro. This is the output of that system. This synchro is connected normally to the polar path coupler I have described several years ago. So you can see here the very tiny wires. You can see here the reverse engineering of this gyro. It is not very complicated. We have here a 3-phase AC motor for the rotor. It is not complicated to find the wires. There are 2 wires here and the third one on the other side. The motor is connected to pins ABC of the connector. There is also the torque motor. There is a winding with a middle point. You can see this coil here. There is a reference winding here, which is connected between these 2 lines here. Normally there is a voltage of 200 volts approximately between each terminal here. The command winding of the torquer is here. It is connected to this leveling switch. Okay, and there is a capacitor here in order to have a phase shift. And we have here the synchro. So it is not complicated to find the synchro. So this is a synchro transmitter. The reference winding is here. It is connected to one pin here. So this is strange, and it is connected to another pin here. There is a common line between the synchro and this point. The voltage here should be 26 volts. For the test, I have connected this synchro transmitter here to this distance bearing indicator. For the gyro itself, I will use a single phase power supply, 115 volts, and I have added here this LC network, which permits to create a second phase. I have defined these values in order to have the same RMS voltage and a phase shift of 60 degrees here. So you can see here I have a capacitor decade box and an inductance decade box. I am going to turn on the power supply. You will see at the beginning a strong oscillation of the gimbal here. So this is due to the leveling. When the velocity of the rotor is low, the effect of the torquer is very strong, and this effect decreases when the velocity of the rotor here increases.